So today I'll be teaching you guys about the limit definition of a derivative, the first one. So the formula that we're going to use is the limit as h approaches 0 of fx plus h minus fx over h. And so the example that we're going to use for this, the one that we're going to find the derivative of is fx equals 1 over x. So to find the derivative of this function, what we want to do is plug in 1 over x into our x's. So what we'll have is 1 over x plus h minus 1 over x all over h. And so now we can't just plug in our limit of 0 into our equation, so we have to simplify. And the reason we can't do that is because 0 can't go into the denominator. Like if we have 1 over 0, that doesn't work. 0 can't be the denominator. So let me erase this and rewrite our equation, and then we can start simplifying. So the first thing that we need to do once we have our equation all written out and we start to simplify is we need to find the least common denominator of our two functions here. And so that will equal x times x plus h. And that's just our denominator. So to find what the top equals, what we need to do is multiply our top number by what is missing in those. So we have 1 times x, because x is missing the first one, minus 1 times x plus h, because that x doesn't have it. So okay. So now what we have to make sure we do is distribute our minus sign. What we'll end up with once we've simplified this further is x minus h over x times x plus h. And that will all be over h. And so what we have is x minus x is nothing, so we can cancel those out. And we just have negative h over x times x plus h all over h. So I have to erase this again so we can rewrite it, and then we will go on to simplify it down and get rid of the h on the bottom. So negative h over x times x plus h all over h. So what we're going to do is take the reciprocal of our denominator here. So h equals h over 1, and the reciprocal of that is 1 over h. So we want to multiply by 1 over h. And we do that, so we multiply by 1 over h. And then the h's cancel. And so what we're ending up with is negative 1 over x times x plus h. And that's our simplified function. So now we just need to bring back our limit. So limit as h approaches 0 of our new function, which is negative 1 over x times x plus h. And then we need to plug in 0 into our h. And so what we end up with is negative 1 over x times x plus 0. And we simplify that down and we get our answer, which is 1 over x squared. Ta-da! So that is our first example. And what we'll do next is the same thing, but just a little bit easier with numbers, not a fraction this time. So our second example, we'll have fx equals 12 plus 7x. And then, so what we want to find the derivative of 12 plus 7x. So let me scoot down here a little bit. We will have, so the derivative f prime x equals the limit as h approaches 0 equals f x plus h minus fx, just like the first one, just like all of them, over h. And so, just like we did, we want to plug those in. And what we'll end up with after plugging them in is 12 plus 7 times x plus h minus 12 plus 7x, all over h again. And then we just want to simplify that out. So we'll distribute, and what we'll get is 12 plus 7x plus 7h minus 12 minus 7x, all over h. And then from here, it looks a little complicated, but it's simple. Our 12s cancel, our 7s cancel, and our h's also cancel. Yeah, so what we get is 7, and that's our answer. We'll circle it here. And that's the derivative of that function.